This is Ham College, episode 142 for July 31st, 2026. Ham College is brought to you by ICOM. Fun, Sun, and QSO. From base stations to portable models, ICOM has the best radios for working your favorite bands this summer. Whether outside enjoying sunny skies or inside by the AC, stay cool with ICOM. Kick back, enjoy the breeze, and make those QSOs with ease. Greetings and welcome to another episode of Ham College. I'm Professor Thomas.
I'm Dean Martin.
And we've got plenty of questions for you tonight on, well, I say plenty. Actually, it's less than normal tonight.
Yeah,
because
it's abnormal.
Yep. Some of them have been deleted out of the pool here. 3 questions out of this group they deleted.
Wow.
Yeah. Not sure why.
What do that for?
I guess they were obsolete or wrong, or they didn't really care anymore. But anyhow, it's good to be back. This is, what is this, July 31st?
Oh, wow. Tomorrow's August 1st?
Yep.
Okay.
So Huntsville will be in, 2-3 more weeks?
About 3. I
About
got
3
my
weeks.
Space Center shirt on in honor of the coming occasion. 'Cause we won't have another Ham College before we go.
That's true. Well, I've got my I=E over R shirt because you just never know.
It's the law.
This could save somebody's life.
Keep him out of prison because you got to know the law.
Yep. What did we talk about on the last episode? Do you recall?
Yeah. Oh, man. It's right there on the top of my brain. Right up here.
So up there somewhere, huh?
Yeah, it was up there. We talked about antenna structure limitations, good engineering, and good amateur practice, beacon operation, prohibited transmissions, and transmitting radio signals.
This time we're going to talk about transmitter power regulations, data emission standards, and 60-meter operation requirements. We're going to talk about those things, plus a little bit of related stuff. First up, though, I've got a little explaining to do.
We're going to get some education before we get to take the test.
Education and demonstration. Not the kind with science.
No aggravation?
Might be a little of that now. I can't make any promises on that. But I'm going to have to get my laptop out here because we're going to need a transceiver. And I just happen to have one that's 20 feet away from us, so my arm won't quite reach it.
So what are we going to be demonstrating?
Well, we're going to be talking about peak envelope power versus average power. So peak envelope power is the average power over a single radio frequency cycle at the crest of modulation. PEP is normally considered the output power at the occasional or continuously repeating crest of a modulation envelope under normal operating conditions. Many regulatory authorities use PEP to set maximum power standards for radio transmitters in certain services. Not all of them. So first, let's talk about AM PEP. Assuming a linear, perfectly symmetrical 100% modulation of a carrier, PEP output of an AM transmitter is 4 times its carrier. In other words, a typical modern 100-watt amateur transceiver is usually rated for no more than 25 watts of carrier output when operating an AM. PEP, peak envelope power versus average power, and average, you can think of that as pretty much RMS.
What's RMS mean?
Root mean squared.
I almost said what's root mean squared mean.
Yep. PEP is equal to steady carrier power, or for CW, a dot or a dash, average power, in a properly formed CW transmission. PEP is also equal to average power in a steady, non-amplitude modulated signal like FM, FSK, RIDI, and some digital transmission modes. Although average power is the same as PEP for complex modulation forms like FM and FSK, the peak envelope power bears no particular ratio or mathematical relationship to longer-term average power in distorted envelopes such as CW waveforms with power overshoot, or with amplitude modulated waveforms such as single sideband and AM voice transmissions. Typical average power of a single sideband voice transmission is 10 to 20% of PEP. Let me say that again. Typical average power of a single sideband voice transmission is only 10 to 20% of peak envelope power. The percentage of longer-term average power to PEP increases as processing and commonly reaches 50% approximately with extreme speech processing. To do this, I've got my rig on the other side of the room here, and I'm using the ICOM RSBA1 software to remotely control it from the laptop. And I'm just going to be using earbuds for a microphone because that'll be good enough for what we want to do here. And although I have talked to some folks at night using this when I was away from the shack here, and they said I sounded about the same. So
really,
you wouldn't have thought, but
no, you wouldn't.
So first thing we're going to look at, let's just look at single sideband here. I've got the rig set for 100 watts. We do have an amplifier on. I've got the ICOM PW2 there running so that we can get a good strong signal and actually see on this meter right here what we're trying to demonstrate. And I think you'll see the difference between average and PEP.
Okay.
This is an MFJ 815C true peak reading SWR watt meter. Essentially, it will display an average reading in watts. If you've got the button out here, if we push it in, it's going to read it. They say peak. The title is true peak reading, but essentially it's going to be reading peak envelope power if we push that button in. So we'll start out with average right here.
That's a pretty average thing to do.
All right, so driving that amplifier with 100 watts should give us 1,000 watts of output power, which would be all the way to the floorboard. We are connected to a dummy load, so we're not doing this over the air. Average power, we're on the 3,000 watt scale. So I'm going to key up the transmitter, single sideband. I've got the little microphone right here up in front of my face. We're talking on it. And let's look what the meter says. There's a little delay because, I am doing this over, I don't know if it's going out over the internet. Well, it is because that's how I have this set up. So the 10 right here, since we're on the 3,000 watt scale, that 10 represents 100 watts. The next line up, 200. So looking at the peaks there, what would you say, Dean? How much power am I putting out?
Looks like about between 150, maybe it may have hit 200 maybe once.
Okay, it's going to vary with my voice and the frequencies in it. Yeah, hit 200 that time. I saw it hit 250 or near 300 earlier. That's nowhere near 1,000, is it?
Nope, not even close.
All right, so that's average power. Let's look at PEP. Let's modulate it now.
Oh, wow.
That's getting a little more what you would expect, isn't it?
Yep.
And I think what they mean by true peak reading here is it's reading PEP power, but it stores it to decay it off slowly so that you can get a good look at what the power is. It's going to vary greatly with what we're modulating it with. So you can see it's doing 900 watts. If I hit it just right, it will say 1,000 watts. 800 watts, that's what you'd expect with sideband. You know, it's going to vary depending on what you're modulating with. There's a lot of difference between that and the average power, which is way down here.
Wow.
Would you concur?
I would concur.
Felt all green for a moment.
Yeah. All that RF, it's kind of made me feel kind of green.
So what did they say here earlier? They said the average power was only 10 to 20%.
20%.
About right, isn't it?
Yeah, it is about right.
Okay. So big difference. In most, I say most, I believe most amateur radio watt meters are going to be displaying average power or RMS power. They're not going to be showing PEP. Some might, but I don't think the majority do. So now let's try a different mode.
Okay.
So you'll agree that single sideband, there's a huge difference between average and peak.
Oh, yeah.
Very, very noticeable. Let's go to, let's try AM. I'm going to reduce the power here on this rig because I don't want to hit this too hard. I'm running 10 watts into the amplifier now. I don't know what that's going to give us here, but we'll see. About 200 watts, a little under. If I pick up the mic here and I modulate it, it actually is going negative there in average power.
Yeah, it means you're below average.
That's what they told me at school. So, anyway, yeah, all right, so that's average. Now, what if I switch it to peak? What do you think will happen?
And we're on AM?
We're on AM.
I think it's going to be pretty much the same.
Well, let's see.
Pretty close. I think it'll maybe modulate up a little bit, maybe.
Same thing, till we start modulating it. Wow, that's close to 4 times as much, isn't it?
Yeah, it is. That's more than I would have thought.
And that's what happens when you modulate an AM signal 100%. It'll be about 4 times, the peak envelope power will be about 4 times the average power. AM's amplitude modulation, so we're changing the signal.
Yeah, that makes sense.
With the modulation. That fan speeding up in that amplifier over there.
I know it's getting pretty toasty down here on my feet. But
we'll have to remember that this winter when it gets cold in here. Okay, this is FM.
FM is frequency modulation, so I think it's going to basically just go to whatever the output power is and stay. And on both average and peak. I don't think it's going to change.
We'll key it up about 400 watts. Let's look at it on peak. First, let me modulate it. Okay, I'm talking in the little mic. We don't see anything happening. Let's go to peak. All right, I'm talking in the mic. Nothing happening.
Nope.
It's about 400 watts either way there. So peak and average are the same for FM.
That makes sense.
Most of the amateur radio stuff, FCC, is specifying PEP, peak envelope power. If you look at something like AM or FM broadcast, they're not specifying it that way. They say you can run 1,000 watts of carrier and you can have a negative 100% modulation with positive peaks as high as 125. And we won't get into all asymmetrical modulation.
ERP's one is going to get a little bit more complicated too when we get around to that.
But
I don't think that's this time, is it?
So So what is ERP? Think about it real hard. Is it PEP or is it average? It's a trick question.
I think it's both.
You got it. It is. It can be measured either way. What would be the reason to use average or PEP? Is it just a preference? It's a good question. And it depends on your meter. If you've bought, well, some of your antenna tuners have a meter in it, and they will allow you to switch between average and peak. Some won't. If there's no option there, it's probably just going to be reading average. But I can tell you from personal experience, I had an MFJ tuner. Well, you got it now.
Mm-hmm.
And it has average and peak both. But it does not read the same thing that this meter does, the true peak reading. And that's because there's no electronics in there to kind of buffer it and
Oh, it's
hold
not
it up.
dampen?
Huh?
Not dampen?
No, it's not delayed or buffered or anything. So by the time you get the peak in there, it hadn't had time for the meter to go all the way up.
Oh.
And so why? Why would you use one over the other? The reason you'd want to know PEP is because that's what the FCC is licensing us for. I'm not going to say because we're fixing to have questions that are going to ask about these power ratings here, or limits. But the FCC specifies the maximum amount of power that we can run on particular bands. Most of them are the same, but not every band. And they specify them in PEP. You'll know what the FCC says you can run. Most of the time you don't have to be that concerned because your gear will probably not put out more than they're going to allow.
Why would you want average, I guess, is
well,
the real question.
So average is easier to measure
Yeah.
than PEP. So more meters will probably be average responding and show your average power. If, though, you're looking at FM or RIDI or frequency shift keying, it won't matter if it's average or PEP because they'll be exactly the same reading. It's only when there's amplitude modulation involved, like with AM or single sideband, that PEP really will be a lot different.
CW?
No, CW is always the same strength. It's either on or it's off. Anytime it's on, it's always constant.
Okay.
It's not, the modulation is not varying. It's just,
yeah, it's just
yeah,
a tone.
yeah.
Sure. Makes sense.
So that's my reason. Maybe someone in the chat room might have some additional information they'd like to share on that I overlooked. Yeah. FM, PEP, RMS are the same, or PEP and average are the same. Ham College is getting its own YouTube channel, youtube.com/@hamcollege-ALTV. So in the future, look for published episode of Ham College right there.
Yeah, go ahead and find it and use that link.
Mm-hmm.
The link will also be in the show notes, by the way. But go ahead and find that and go ahead and subscribe so you won't miss any of the published episodes. What is the maximum transmitter power an amateur station may use on 10.140 megahertz? A, 200 watts PEP output.
B, 1,000 watts PEP output.
C, 1,500 watts PEP output.
Or D, 2,000 watts PEP output. Okay, so all the answers they gave us were PEP. There's no average involved there. So that makes it a little easier. 10.140 megahertz. Well, I happen to know what the answer is. That band, around 10 megahertz there, That's where WWV has a signal.
Yeah.
They're right on 10 megahertz. We got a ham band right above it. I just happen to know that band is a little different than the other ham radio bands in that our maximum power output is different on that band. As well, I believe the modes we can operate on that band are different too. I don't have a band chart in front of me here. I should. Do you have one in front of you?
Oops, if I don't tear the place apart. I may have one in here.
Okay.
Sing the theme song while I look for it.
Anyway, I know what the answer is, and while he's looking for it, I'll just go ahead and go straight for it. I believe the answer is A, 200 watts PEP output.
Is that 30 meters?
It's 10 megahertz. Is that 30? Yeah, that probably is 30. We didn't get many answers over there. We got a C. We got an A.
Oh, here's one. It's not a current one, but it's
That's good enough. Yep. So, yeah. So what does it say? 10 megahertz.
Sorry. Here, you got it.
Yeah. 30 meters. 200 watts PEP. And it's red. And what does that red mean? The whole band is red. Only Ridian data.
Yep.
Can't do any sideband, any AM, FM. And Terry says it's different over there. And yeah, it probably is. Different country. Different rules on that. So it is 200 watts PEP output. What is the maximum transmitter power an amateur station may use on the 12 meter band? A, 50 watts PEP output.
B, 200 watts PEP output.
C, 1500 watts PEP output.
Or D, an effective radiated power equivalent to 100 watts from a half-wave dipole. 12 meters. I think, okay, so we did the one exception that I'm aware of. Actually, I think 60 meters might be an exception too. But 12 meters, I believe, is going to be the C, 1500 watts PEP output, which is what most of the HF bands here are in the U.S.
Okay. Well, let's see what everybody says on that one before we go straight for it there. So what is the frequency for 12 meters there in megahertz?
24.
Everybody's saying C. I'm agreeing with you. I think it's C as well. And it is.
But it's the maximum bandwidth permitted by FCC rules for amateur radio stations transmitting on USB or upper sideband frequencies in the 60 meter band. Aha. A, 2.8 kilohertz.
B, 5.6 kilohertz.
C, 1.8 kilohertz.
Or D, 3 kilohertz. Okay, what's the maximum bandwidth permitted by FCC rules for amateur radio stations transmitted on USB frequencies in the 60 meter band? 60 meters is, that band's a little complicated.
Yep.
It's like 10 megahertz there. The rules are a little bit different on it. 60 meters is channelized. In other words, there's certain frequencies you can operate on, and the modulate or the sideband modulation there is upper sideband. Although there is some digital on there as well, and I think that's specific to certain channels. I know it's not 5.6 kilohertz. That's pretty broad.
Yeah, I don't think that's for any HF.
I don't think it's 1.8. That's pretty narrow. I think it could be 2.8 or 3 kilohertz. Either one of those sounds pretty typical for sideband. But on this particular band, 60 meters, I'm going to say A, 2.8 kilohertz.
I think that's right. I know it's something different about it.
Mhm.
3 kilohertz is what we normally use most of the others, so I'm thinking it's probably A also.
A little mix in the chat room there, and it is a 2.8 kilohertz. Which of the following is required by FCC rules when operating in the 60 meter band? A. If you're using an antenna other than a dipole, you must keep a record of the gain of your antenna.
B, you must keep a record of the date, time, frequency, power level, and stations worked.
C. You must keep a record of all third-party traffic.
Or D, you must keep a record of the manufacturer of your equipment and the antenna used. Okay, so it's not going to, I don't think it's going to be D. It's not going to be C, I don't think. Using an antenna other than a dipole. I think it's going to be B. Because I think that's shared, isn't it? 60 meters shared.
It is shared. We're secondary users.
Yeah, so I think that makes sense to me that you would want to keep the record of the date, time, frequency, power level, and your station that you worked, which you probably should do anyway in a normal log. But I could see why it would be important there on 60 meters. So I'm
Okay.
going with B, Bravo.
All right. Chat room, not many answers on that.
These are kind of tough, man.
Yeah. We got a couple of A's there. I'm going to agree with them.
Oh, okay.
And it is. The frequency and the power level.
Did I hear a buzzer?
That's what that was. Yep.
Doggone. I got buzzed.
Yep. So frequency, there's only certain frequencies you can operate. You can't just spin the VFO and go down the dial.
Right.
They've got it channelized to specific frequencies. Power level, there's a specific power level you can run there as well that you can't exceed. And I didn't know that you had to keep a record of it, but basically they're saying if you're not using the dipole, then you need to keep a record to show that your effective radiated power is going to be the same.
What is the limit for transmitter power on the 28 megahertz band for a general class control operator? A, 100 watts PEP output.
B, 1,000 watts PEP output.
C, 1,500 watts PEP output.
Or D, 2,000 watts PEP output. What's the limit of transmitter power on the 28 megahertz band? So that's a 10 meter band for a general class operator. Because, and it's important they say general. If a general can do it, an extra can do it. But also technicians have some privileges on 10 meters.
Mm-hmm.
But they can't operate the amount of power that a general can. So we know it's not 2,000 watts because the
Nobody
FCC,
has 2,000.
yeah, they don't allow any of the bands to have 2,000 watts PEP. 100 watts, it's more than that. The maximum you can run on most of the HF bands as a U.S. amateur is 1,500 watts PEP. And I believe that applies to the 10 meter band as well. So I'm going to say C. Chat room is saying C. And it is.
C.
Fun, Sun, and QSO. From base stations to portable models, ICOM has the best radios for working your favorite bands this summer. Whether outside enjoying sunny skies or inside by the AC, stay cool with ICOM. Kick back, enjoy the breeze, and make those QSOs with ease. Remote ready, contest capable, and built for serious signal, step into the future of amateur radio with ICOM's Powerhouse Trio. The IC7760 HF 50 MHz digital transceiver, the ICPW2 1kW HF 50 MHz linear amplifier, and the all-new RC7760 remote controller. Designed to work in perfect harmony, this system offers full remote operation, high output performance, and seamless integration across the bands. The RC7760 remote control serves as an extra control head, and up to 5 can be registered to the RF deck, though only one can be active at a time. For wireless connectivity, simply connect a commercially available Wi-Fi access point via the LAN port. Whether you're working from the shack, the field, or a remote site, you'll experience crystal clear audio, digital precision, and amplifier-grade power, all from a single unified interface. It's the ideal setup for contesters, MCOM operators, and high-demand users who expect more from their gear. Together, they redefine what's possible in amateur radio, setting a new standard for global connectivity and reliability. The IC7300 combines intuitive touchscreen control, real-time spectrum display, and superior signal purity into one compact rig. Serious performance for serious operators with the IC9700 VHF UHF 1.2 GHz all-mode transceiver. Whether used as a club setup or a personal portable station, the IC705 delivers capable ICOM performance when every contact counts. For more information about all of ICOM's great amateur radios, visit icomamerica.com/amateur today. What is the limit for transmitter power on the 1.8 MHz band? A. 200 watts PEP output.
B. 1000 watts PEP output.
C. 1200 watts PEP output.
Or D. 1500 watts PEP output. 1.8 megahertz, that would be 160 meters. As far as I know, that falls under the kind of the blanket 1500 watts or 1.5 kW. So I'm going to go with D, 1500 watts PEP output.
And I would say you are correct. Chat room is saying D. There you go.
Yes.
You got one for me?
Man, I got a good one right here for you.
Uh-oh.
Good wordy one. What must be done before using a new digital protocol on the air? A. Type certify equipment to FCC standards.
B. Obtain an experimental license from the FCC.
C. Publicly document the technical characteristics of the protocol.
Or D. Submit a rulemaking proposal to the FCC describing the codes and methods of the technique. What must be done before using a new digital protocol on the air? A. Type certify equipment to FCC standards. We're amateurs, so our equipment, I don't believe, has to be type certified, or at least the protocol doesn't. B. Obtain an experimental license from the FCC. Well, no.
I've never heard of an experimental license.
We're amateurs, and that's part of the expectation is we're going to experiment some. So we don't have to have a
That's the cool part,
license.
too.
There are experimental licenses for other services like broadcasting, but
not for hams.
Not for hams. D. Submit a rulemaking proposal to the FCC describing the codes and the method of techniques. They don't want to be burdened with your rulemakings and possibly a protocol that doesn't go anywhere. C. Publicly document the technical characteristics of the protocol. That's my answer. I'm going to say C. Chat room is saying C.
I see.
So, and why would they want you to document the technical characteristics of the protocol publicly?
So they can decode it. You're not supposed to have anything encoded. Like no hidden meanings.
Right.
Except for the communications to the satellite stuff, control codes, but like we mentioned last month. But so you don't So anybody can use that and figure out how to decode your messages.
Yeah. If you publish it publicly,
So what does that mean by publicly? That means just put it on your website or something, or someplace where it can be found?
or publish it in a magazine article, or maybe the Federal Register. I don't know. They don't specify where, but publicly document it
publicly.
somewhere.
Put it
Yeah.
on the internet.
Yeah.
It's hanging in my window
Where are you going to put it on the internet?
on my website.
Okay. And that is, I'm going to write it down.
amateurlogic.tv
Okay.
or
And,
hamcollege.tv.
and so
They
what,
have two of them.
what are we calling the new protocol?
Don't get me started.
What measurement is specified by FCC rules that regulate maximum power? A, RMS output power from the transmitter.
B, RMS input to the antenna.
C, PEP input to the antenna.
Or D, PEP output from the transmitter. I'm going to go with D.
Okay. We've got a C and a D in there.
You guys aren't answering very many tonight. These are
No.
these are a little bit tougher than I thought they were going to be.
It's
It's only 8 questions, but they're 8 tough ones.
It's D. No. But yeah, it's D.
That's the one. That was what
Yeah.
I chose.
Yeah.
You want to check it?
Mm-hmm.
Okay.
It is. Couldn't you have an amplifier between the transmitter and the antenna? Yeah, but the amplifier would be considered part of the transmitter, I believe, is what they're talking about there. Doesn't say amplifier, so it's a good question, but no, transmitter would include the amplifier as well if you got one.
What if you got one that's in the closet?
You got it hooked
That's
up?
where, no, it's in the closet.
Well, then I don't think that really counts.
I need to get hooked up. Soon as it gets a little bit cooler, I'm getting the attic where I can run my power line.
And that is the last question for tonight.
Get out of here. Really?
That's it. There were 11 questions in this sub-element, and questions
-3.
8, 9, and 10 were deleted. So I don't know what those questions were, but we don't have to worry about them. Yeah, you are late, Marty, just in time. No, you didn't
have
get
a
expelled.
note. You need a note from your mom. You ever watch Welcome Back, Kotter? Long time
Like in
ago.
the 70s.
Yeah, well, that's when it came out.
Yeah.
Remember Epstein? They always said those notes signed Epstein's mother.
Oh, yeah. Okay. We've got one more discussion tonight, sort of related to what we were talking about earlier.
Sort of, kind of.
Yeah. Left-hand side, we've got a transmitter. The output of that transmitter is the transmitter power output,
Or the TPO.
or the TPO. Then there's usually a connector there.
Yep.
Then you've got transmission line. In this case, we're using coax. Then you've got another connector that's connecting to the antenna input. And coming off of the antenna, we've got effective radiated power. And the reason ERP is not the same as TPO is because there is loss in those two connectors. There's also loss in that transmission line. What we are not showing there is the antenna tuner, which could have some loss as well. If we had a meter in line, might have a slight amount of loss there. But that's, say, a typical setup.
Yeah, except my antenna don't really look that cool. But yeah.
No, it doesn't. And here's where it's going to get really weird. Your antenna is not really that cool. And neither is the one that we're going to talk about now. Because to make this more explainable, we're going to use 440 megahertz.
Ooh.
You would never use a tower by itself to be an antenna for 440 megahertz unless it was maybe 3 feet tall.
Yeah, I've never screwed the connector into the leg of a tower either.
It's hard. You have special tools. All right, so let's look at an example here to figure out effective radiated power. We got a transmitter output power of 100 watts. Okay. This connector is going to have at 440 megahertz, and that's why I chose this frequency, is because down in the HF bands, that connector would have very, very little loss. But typically, this frequency, that connector is going to have a half a dB loss, minus 0.5 dB. The transmission line, we're going to use RG8 transmission line, which you would not want to use for UHF, not for 100 feet anyway, because you're going to have 100 feet of RG8 as a minus 3.1 dB at 440 megahertz. Now down at 2 meters, it's not as much loss. Down at HF, 100 feet is almost negligible. It's so low a loss. Higher in frequency you go, the more these connecting components here are going to attenuate.
More lossy they're going to be.
More lossy. We got this other connector going to the antenna.
Leg.
Well, for 440 megahertz, there's not going to be an antenna like that. But I'd already drawn this when I figured we were going to have to go to 440. So, PL259 connector, another minus 0.5 dB of loss. So our total losses, 3.1 dB for the transmission line, and then 0.5 for the connector on the transmitter, and another 0.5 for the connector at the antenna. So overall, we got minus 4.1 dB of loss. They're starting to add up.
Mm-hmm.
All right, now let's say the gain, our antenna's got 5 dB of gain. That sounds good.
Mm-hmm.
But we've already wasted 4.1 dB there just getting the power to the antenna. What we're going to end up with is plus 0.9 dB of gain instead of 5, because we lost 4.1 getting it there. And that'll give us an effective radiated power of 123 watts. So our 100 watts with 0.9 dB of gain, we get 23 extra watts.
Wow.
ERP. Our transmitter power is still only 100 watts, but our effective radiated power would be 123
So without
watts.
all those losses, you would, if at 3 dB, you would end up with close to 200 watts around. See, that's a lot of loss.
It is a lot of loss. That you're losing a ton there,
Most of it.
most of it in the transmission line, but you're losing a dB in the connectors. PL259s are not really good UHF connectors.
What would be the loss of an end connector? Which
It'd be
what
much
you-
less. I don't know off the top of my head, but that's what would be recommended. It would be a type N or a B and C maybe. So I didn't show you how to calculate out the ERP, and I didn't do that because that gets into some more math, and it wasn't part of the questions tonight.
Yeah, I'm
Really.
sure that'll come up though.
This is
At some
the
point.
this is beyond the scope of the questions tonight, but I wanted to give some kind of example to show, basically the difference between transmitter power output and effective radiated power. The way I came up with the answer, rather than do the math, I just went to the internet, this site, M0UKD, and he had a calculator there. I put in 100 watts, and I knew, figuring the losses, we had 0.9 dB D of gain. Click calculate, and 20.9 dBW, which is 123.02688 ERP.
Tom says type in connectors at the frequency is about 0.1 dB.
Yeah, much better. What's strange about that, and we've talked about it before, that connector, the PL259, you know what the real name of it is.
UHF connector.
Yep.
Yeah. don't really understand that.
It's because that's a military spec, PL259. At the time they spec'd that connector out, UHF was 30 megahertz.
Oh, yeah, we talked about this
Yeah.
recently, didn't we? I forgot.
Yeah. We didn't have any gear, and now it's 300 megahertz. That's a big change. Oh, dear Dean Martin, Professor Thomas, Marty, AD0PO, was late to class tonight because he's just slow sometimes. He did bring dinner home, so he's sort of redeemed himself.
I'm
all
waiting for mine, too.
Thank you for trying. Now she
That's
just
awesome, Marty.
totally redeemed him there, or did he? So
That's pretty good, Marty.
That is good.
I like it.
Anything else we need to cover before we get out of here tonight?
No, I think that's it. Just if you guys are in around the Huntsville area, what's the date of that? It's 22nd and 23rd for sure of August. If you're around the Huntsville area, come on to the Hamfest. I'll be around there on Saturday. George will probably be there for part of both days.
I will probably be there for part of both days.
But I usually just go for Saturday.
22nd and 23rd. So, yeah. Wayne and I will be going again this year. We always, we might not talk to each other throughout the year, but when it comes time for Huntsville, it's kind of like an unspoken deal that,
catch up time.
yeah,
That's
we're
cool.
going to drive over.
Yeah, it'd be good to see Wayne. I hadn't seen him since, I guess maybe at the Jackson Hamfest. He was there for a few minutes.
Yeah.
Didn't talk to him long, but anyway, it'd be good to see him catch up again.
Yep. Join us right back here on Amateur Logic, August the 14th, Friday the 14th.
Oh, man.
Just barely missed it.
When am I going to get to use my Jason mask again?
I don't know. It'll be coming up. We had a lot of Friday the 13th last year, I think.
Probably got them all got them all used up for a while.
Good.
So that's 2 weeks from tonight, and then the following week is the Hamfest.
Yep.
Then the following week, I guess after that, will be
Probably be Ham
Ham
College.
College again.
Yep.
Then the next weekend is the Slidell Hamfest.
Wow. It gets busy this time of year, and then Hamfest season will be over before you know it.
Then it's time to go buy Christmas presents.
Yep. And I will be getting you a list of what I would like this year.
Okay. Well, I've already got mine. Emailed it to you.
It ended up in my spam box.
That's the same thing my wife said.
Yeah, okay. All right, I got to get to working on my shopping list for the Hamfest. I need some rope.
Some rope.
I need some more mastering rope. I've about used up my 250-foot spool that I bought for a different project.
Well, they'll probably be there.
Yeah.
They were there last year.
Yep.
Yeah, it's good stuff. I bought 1,000 foot of that other paracord.
Yeah, I'm interested to see how that lasts when you put it up permanent.
Yeah, me too. So we'll see.
7-3, everyone.